mitigate, to transfer the risk, to ensure that its impact on our project is minimized and the project succeeds as appropriate. The first step in doing risk analysis is doing a qualitative risk analysis. Doing the prioritization to understand which risks require further attention and which risks, although risks are of such low priority or such low impact to the project, can effectively be ignored. As a project manager, you need to ensure you're dealing with the high priority, high impact items, and as unfortunate as it may sound, that you're allowing the low impact, the low priority risks to be ignored and simply something that would be dealt with should they occur as part of routine project delivery. So you need to go through and do a further, more detailed analysis of the probability and the impact of the risk. That may mean opening up the risk impact assessment matrix that we developed during project risk identification and reevaluating, determining the impact of the risk on your project. Now that we're in qualitative analysis, we should have more information, more details related to the risk, and again, we may want to go back and reassess some of the values, some of the assessment we did during preliminary risk identification. We may need to put the risks on a further impact matrix to further understand which risks truly warrant our attention and truly warrant active risk management, and which risks, as I said, can simply be ignored and dealt with during routine project delivery. It's critical that we put the risks on a timeline. As a project manager, you have more things to do in a day than you have hours in the day to do, so it's important that you prioritize and understand which risks are likely to happen in the near future and warrant your attention, and which risks are likely to happen further out in your project timeline, and simply put those on a to-do, brought forward list to be dealt with when they become true active risks for your project. You need to ensure that you're focusing on the right risks. You need to ensure that the risks that are going to impact your project in the near future are receiving your attention, and the risks that are going to impact your project in the future are on a brought forward list, and that the low priority, low impact risks are on a casual watch list or possibly even on an ignore list. So how do we go about doing all of that? First thing, we need to go back and reassess our risk impact. So here we have the risk impact that we put together for inadequate training. Now that we're in qualitative analysis, we need to review and understand, is in fact each one of the evaluations that we put together for this particular risk appropriate? Is in fact cost of less than 5% the appropriate number? We have gone through and done more analysis of this risk, and possibly we're saying, no, less than 5% really isn't the appropriate value. That needs to be raised, and let's put it into the greater than 10% range. So we increase that value. If we're looking at the time, is the impact of time still greater than 25 days? And we're going to say, yes, absolutely, the impact of time is going to be 25 days. We're still comfortable with that. What's the impact of scope on the project? Is the definition of scope or the impact of scope still deemed to be insignificant? And again, our preliminary assessment is probably true in that particular instance that poor code is not going to change the scope of the project. Poor code is simply going to take more time and more cost for the project, but we're reassessing the impact of quality, and we're saying, poor code is going to probably have more than a potential for problems on our project. Poor code is probably going to have a significant impact, significant impact for our project, and we need to change the impact assessment for that as well. So we need to go through and reevaluate the probability and the impacts of each of our identified risks now that we're going through doing more detailed analysis of the risks. In this particular instance, we see the result is still medium, so although we have done further analysis of the risk, we in fact haven't changed the risk ranking for the project. Some risks do not warrant this level of detailed analysis. Some risks you can simply get away with doing a higher level risk analysis. So here is a very high level risk analysis matrix grid evaluation form that I've put together that again I often use for lower level, less critical risks, or for risks that we simply do not have the level of detail that we need to fill in the previous matrix. So here we simply do an assessment of probability on a low, medium, high ranking and the impact on a low, medium, high ranking, and determine which one of these 9 matrix points that the risk falls into. And if you simply say the probability of the risk is medium and the impact of the risk is high, that's going to be classified as a medium risk. If the probability of the impact is high, but the impact is low, you may still say that is a low. We don't care about that risk. That risk can be effectively ignored and dealt with as we go forward. So again, this is just another high-level matrix that you may want to use to determine your overall project risk impact. And then finally, dealing with the timeline, we'll come back to our risk register, and we will see that we have inadequate training. The probability impact is medium. We have not changed that as a result of our reassessment, but we need to look at the critical date. Now we need to put this on a timeline and assess when and where in the project do we as a project manager need to begin to focus on risk. So to keep this generic, I'm simply going to say the critical date for inadequate training is going to be in month 4 for our project. In a true project delivery scenario, month 4. Let's make that month 4. In a true project where you have an actual project plan in place, you would be able to say this is going to appear in June or August or September. At this point in time, because we're dealing at the high level, we're simply going to say in month 4 for this project, the project manager, you need to start focusing on the impact of inadequate training, start to assess how well the team is performing, start to assess whether in fact you are going to have training learning curve issues, or whether in fact that preliminary 5 days of training from our vendor is sufficient and adequate to deal with the project delivery environment. The next step in risk analysis is a quantitative analysis. Quantitative analysis involves assigning numerical values to the risk. Typically, quantitative analysis, because it is fairly intensive, requires significant effort on behalf of the project management team to do the quantitative risk analysis, is reserved for the high risks, the risks that have a high probability of occurrence, the risks that have a high impact on the project. Other risks simply will go through the qualitative analysis, assignment of the low, medium, high ranking, and go directly to the risk response planning strategies. The higher priority risks may go through the quantitative analysis. And again, I want to stress, not all project risks need to go through the rigor of quantitative risk analysis, but some high priority risks, the risks that truly have a significant impact on your project, the risks that require significant attention by you, the project manager, to ensure that their impact on your project is going to be minimized, will require a quantitative analysis, and that is to assign a numerical rating, potentially to come up with the exact equivalent of the dollar value or the time equivalent of what is going to be involved in the project to ensure you have appropriate strategies in place to deal with the risk. Two of the most common forms for doing quantitative risk analysis is to do a Monte Carlo simulation or to do a decision tree. A Monte Carlo simulation, for those of you unfamiliar with the term Monte Carlo simulation, involves running mathematical models, doing mathematical simulations to determine the probability and the impact of the risk. So you would assign a probability curve that on a low level probability, the impact to the project is going to be this. On a medium level probability, the impact is going to be this. On a high level probability, the impact is going to be this. You would put that into a piece of software, Monte Carlo simulation software, and it would run the simulations thousands of times to come up with a probability distribution based on standard distributions. The likely impact to the project is going to be a final value based on a wide range of simulations using Monte Carlo software. Another form for doing quantitative analysis is decision tree analysis, where you break the risk event down into a number of subsequent actions and assign and determine the value of the risk associated with the branches of the decision tree. With the decision tree, you start with the root cause of the risk. When you do decision tree analysis, You take your original problem, inadequate training, and then you begin to analyze what the impact, how inadequate training is going to play out on your project. So we broke an inadequate training down saying everyone, or essentially the entire team, is impacted by the inadequate training, and everybody is performing below anticipated levels of performance, or only some of the team are being impacted by the inadequate training and therefore performing below acceptable levels. Then for each one of these, you determine what your appropriate actions are going to be. So we could ignore and assume it's going to get better. We could immediately provide more training, or we could bring in experts to supplement the team, to provide peer support, to provide buddy programming approaches. Same thing on the sum. We could ignore, we could reassign those staff and bring in additional staff, or we could provide additional training to those team members who are impacted by the learning curve issues. Then you need to assign the costs and the impact to the project for each of these activities. So if we're going to ignore it, we feel it's going to be another $5,000 worth of impact, and I'm doing this in a monetary value. You could do the same in a time frame value, but we're saying there's going to be a $5,000 impact for the continued lost productivity until the team comes up to speed, and we give that a 10% probability. More training. It's going to cost a lot to send the team off the training again. It's going to cost $10,000 to send the team off the training, and we give that a probability of 50%. I.e., if we determine that the entire team is suffering from a lack of experience, lack of knowledge with the new programming tool, we're saying probably most likely we're going to send them off to give them more training, or the other option is to bring in experts, and experts are very expensive to provide the peer support. We bring them in, but we're really thinking that may be a very strong probability, and we're going to give that a 75% probability that that will be our solution to bring in the experts. On the ignore, again, what's the cost? It's going to cost $2,000 as not as many team members are impacted, and the probability is going to be 20%. If we decide to reassign, there's going to be some impact because we're going to have learning curve associated with bringing the new team up to speed. Because the original team itself is not performing appropriately, we're putting the reassignment at a very low value, but there's going to be significant other impacts to the team as a result of team dynamics, so we're giving it a probability of taking that action of only 40%. And finally, provide more training. It's not going to be as expensive as providing training to the entire team, so we're ranking that at a $5,000 level and a 50% probability of the action that we'll take. So once you've completed the decision tree, identified all of the appropriate actions that you're going to take based on the scenarios for the project, determine the cost and the probability, you simply begin to do the math where you take $5,000 at 10%, or an expected value of $500, plus the training at $10,000 at 50%, or $5,000, and so on for each of the others, and you come up with an expected value of $24,100 is the overall budget that you should be setting aside based on inadequate training and the possibility that everyone may be impacted by the lack of training, only some, and the various actions available to you to remedy that, times the cost and the expected value, the anticipation of which one of these actions you will take. Obviously, you have more than one action that you'll take now because you don't truly know the impact. You need to meet with the team once you determine inadequate training and ask them, should we be ignoring it? Is this going to go away? Are you just about to beat the learning curve? What do you think the right solution is going to be? Would you like more training? Would you like to bring in the experts? And only in the actual project delivery situation will you be able to make the decision as to which one of these actions is appropriate, but you know the value and you have an anticipation of which action you're going to take. Therefore, you know what monies you should be setting aside, what the anticipated impact to your project is going to be of taking these actions. You know what you need to be setting aside to deal with this scenario should it happen in your project delivery situation. This value that you're seeing as a result of the decision tree analysis, $24,100, you may quickly realize is higher than any one single action associated with remediating our inadequate training. Why is that? That's simply taking the realization that even though we bring in more training, or even though we decide to bring in the experts at $10,000 or $15,000 respectively, that in and of itself may not be our solution as well, that we may need to take other actions. After more training, we may need to still provide additional training or provide additional time to some team members to come up to speed. So this number of 24,100 is based on the realization that we may need to take some or all of these actions as a result of inadequate training. This causes a great deal of concern, a great deal of soul searching for every project manager is, what is the true number I should be setting aside to deal with my project risks? Is the worst case scenario of 24,100 the appropriate number to be using? Is the largest, in this case the largest value, saying worst case scenario, if I have to take a single action, I will bring in experts, so perhaps $15,000 is the right number? Is the average of all of your numbers, so if you take each one of these individual actions and average them together and come up with an average or a weighted average? The problem / issue with risk management is there is no right answer. The right answer is, what do you feel you need reserved as a project manager to deal with the issue of training? What's the probability that inadequate training will hit your project? So you need to know the probability at this point, which we will have from a probability impact assessment matrix that we did. What's the likelihood that it's going to impact the entire team? What's the likelihood that it's going to impact only some of the team? What's the likelihood that a single action will be sufficient to remediate the problem? What's the likelihood that you may have to take experts and additional training for some of the team members? You need to take individual risks, individual assessment of the probability of risks, individual assessment of the impact of risks, and determine what is the right number. Is there a decision tree analysis, evaluating each and every possibility the right number? Is the highest possible number the right number? There is no right answer. The right answer is, what do you feel you need as a project manager in reserve to deal with the training, the actions you must take to remediate training based on the probability of training or inadequate training happening on your project, and based on the overall impact that that risk is going to have on your project. Risk management, the fact that we're dealing in unknowns, the fact that we're dealing with an unknown possibility of training happening, we don't know in advance whether it's going to impact the entire team or only some of the team, and we don't know in advance what the appropriate remediation action is going to be, causes us great concern as to what is the right number we need to be putting into reserve to deal with the training or inadequate training issues should they happen. And unfortunately, the answer is there is no right answer. The right answer is, what do you as a project manager feel is the appropriate number? I tend to believe that somewhere in the range of the 24,000 may be the appropriate answer, simply because it's accepting the fact that you may need to take multiple actions based on the fact that there's absolutely a degree of imprecision related to each and every one of these numbers that you have evaluated. There's a degree of imprecision related to the degree of probability that this is the appropriate action you're going to take. You need to ensure you have sufficient contingency in hand to deal with this risk should it happen on your project. But, and this is the big but you also need to ensure that you're not building in so much contingency that this number is not so conservative that the acceptors are not going to accept the overall project budget, that the project is going to be priced at an unreasonable level, that management and the business is going to say, well, if the project is really going to cost $15 billion, there's no way we're going to take on the project. And I say that with extreme. But the risk is, if you are overly conservative, overly pessimistic with determination what your appropriate risk allowances should be, you're going to overprice the project, and the project is not going to be approved, and therefore the business itself is going to suffer because there was a valid justification for project. Doing your quantitative and qualitative analysis for risk is dealing in unknown, but the expectation is at the end of dealing with these unknowns, you have developed a firm strategy. And this doesn't make sense, I realize that. You're dealing with unknowns, but you're expected to develop a firm strategy for the money and the time that you need to successfully deliver the project based on risks. Therein lies the problem, the catch-22 with risk management. You're dealing with unknowns, but you need to come up with hard and fast numbers for dollars and for time that you need in reserve to successfully deliver your project. The best answer is, what do you believe is the most likely situation? What do you believe is the most likely set of actions you will have to take based on the probability and impact of this risk that you will need to take as a project manager to be able to successfully deliver your project? Once you have completed your quantitative and qualitative risk analysis, it's time to complete the risk analysis process with the definition of your actual risk response plan. With risk response planning, you're defining the actions you're going to take as a project manager, as a project team, to deal with the risks, each and every one of the identified risks. Your basic strategy for risk responses is you can avoid the risk, you can transfer the risk, you can mitigate the risk, or you can accept the risk. So what does risk avoidance mean? Risk avoidance means ensuring the risk does not happen. You're actually changing your plan. You're changing the plan to put appropriate actions in place to ensure the risk event will not happen. What does that mean? Let's take the example we've been following throughout, inadequate training. As a result of doing our analysis of risk or inadequate training, we identify that the probability, the impact of inadequate training is going to be very high, is going to be extreme for our project. So what can we do about it? In advance, before the project even starts, we take the appropriate avoidance strategy, we change our plan, and instead of providing 5 days of training, we instantly go back to our training vendor and say, we don't believe 5 days is enough. We want to ensure our project is going to be a success. We're going to build that additional training into our plan on day 0. We're going to avoid the possibility of inadequate training. We're going to provide that extra training in advance. So effectively, you have avoided, you have changed your project plan, and you have ensured that you have taken the appropriate action, or as much appropriate actions as possible, to avoid having any risk of inadequate training happening on your project. Transference. Effectively making the risk someone else's problem. Now, this is not as negative, this is not as bad as it sounds. A most common form of risk transference is buying insurance. If there is a risk that your project is going to be impacted by weather, if you live in an unstable climate where there is a risk of fires, floods, earthquakes, you may want to take out insurance that is going to insure both your property and insurance that is going to provide some financial recovery should your project be impacted by insured events. So effectively, by taking out insurance, you are transferring the risk of environmental impacts on your project and getting insurance that will cover the risk event and ensure that your project is able to complete with no true impact to the organization. Another form of transference is to contract out. As part of doing your project plan, you determine there is a risk that my project team will not have the skills to complete a certain subsection of the project. We have a very technical interface that must be created. Our team is not experienced in that specific aspect of the interface, So therefore, you create a contract with an external firm who are experts in developing the interface, and you say, I am transferring this part of my project plan to you. I am ensuring that you, the experts, have the responsibility for delivering this intricate, complex part of the project. You have transferred the risk from your project to an outside agency, and they have taken on the responsibility. With transference, whether you're buying insurance or whether you're contracting out, you're typically paying a premium. You are paying an extra price for your project for the insurance policy. You are paying an extra price for your project for the contracted experts to ensure the risk event that you anticipated does not happen on your project. So with both avoid and with transfer, you are taking proactive steps. In both instances, you're actually changing the project plan. You're changing the project approach to eliminate the risks before the project even begins. So effectively using both an avoidance and a transfer strategy, you are ensuring that the risk event is eliminated. There will be instances where you simply can't eliminate the risk, that the nature of the project or the nature of the risk says there's no way I can change my plan to avoid it, or there's no way I can change the plan to transfer, there's no way I can buy an insurance, or no way I can contract out. So then you're going to take the appropriate actions to mitigate. What can you do to lessen the impact? So again, you're taking appropriate steps to minimize the risk for the project. But in the case of mitigate, you can't eliminate, so you're doing whatever you can to lessen the impact. So again, let's go back to our example of inadequate training. You decide that the avoid strategy of moving from 5 days to 10 days isn't appropriate, too expensive, too much impact to the project schedule, but you may take the appropriate mitigation actions is I'm going to send the team on the original 5 days worth of training, but I'm also going to ask the trainer to come back and provide peer review for the first few days of the project. So you're taking the appropriate actions to mitigate. So effectively you are again changing the project plan to minimize the impact for the risk, but with mitigation you still need to have appropriate contingency, dollars or time, based on the fact that your mitigation strategy may not be sufficient to eliminate all of the risk. So over and above the incremental costs that you put into the project plan to have the trainer come back, you need to build additional contingency into the plan to deal with the risk should your mitigation strategy be insufficient and you still suffer from inadequate training. And finally, the last and sometimes only strategy you can have for risk events is accept. There's nothing you can do to avoid it. There's nothing you can do to transfer it. There's nothing you can do to mitigate it. You simply have to accept the fact that there are some project risks, although you hope they're not going to happen. There are some project risks that are going to impact your project, and all you can do is accept the fact that should it happen, it happens. Sounds like a very defeatist attitude. In one essence it is. There's nothing you can do about it. But when you decide to use an acceptance strategy, you absolutely need to ensure you have the time and the dollars, the contingency, the reserve built into your project plan to ensure that when there's nothing to do but accept the risk, that you have the allowances built into your project plan to ensure that your project plan is not going to be negatively impacted by the risk. You do risk response planning for each and every identified risk. As you're going through doing your risk response planning, you go back to the original risk register, and once you have determined what the appropriate strategy is going to be, we say we are going to mitigate, bring trainer back, and contingency, my typing is good, isn't it? Contingency of $5,000 and 10 days, or whatever the appropriate risk management strategy is going to be. So you've done the analysis, you've understand the impact of inadequate training, You've done the qualitative and quantitative where appropriate. And again, I want to re-stress, you do not always need to do quantitative analysis, but where the impact is high or the probability is high, you may need to do quantitative analysis through your decision tree analysis, your Monte Carlo simulation.